Hi, welcome back to educator.com. This lesson is about some of the issues that arrive when using XML. XML has, over the past decade or more, revolutionized many areas of online data storage and documentation, but it's not perfect. This has hindered its adoption due to confusion on the part of a lot of people, or just a desire not to get back into their web code and redo it in any way. And this has hindered XML's adoption, which is kind of a shame because it offers a lot of promise for advancing the web to the next level. So in this lesson, we're going to talk about some of the issues that arise. One of the main issues that arises is when we confuse XML with HTML. We're going to talk about how they're different, specifically in the design of documents. We'll take a look at what the effect of text encodings on the successful processing of an XML file. And we'll take a look at media types and how they are handled by different XML processors. The issues of conformance to the standard, both from the authors and programmers, and hinder full adoption of the standard to push the web forward. One of the first things people like to do when they first learn XML is to try to create their own custom copy of HTML. And it's important to understand that there are distinct differences between the two languages, and in particular, between the kinds of programs that are designed to handle them. HTML has been around for just about 20 years now, actually more if you count some earlier efforts. And it and the browsers and other types of programs that process HTML have evolved to handle a bunch of different types of data. So HTML handles text markup, which is what it originally was planned to do. Its use of hyperlinks and hypertext make it more of a user interface type of thing. And then as people tried to add functionality to browsers, we had support for different types of images and other software objects, such as Flash movies or Java applets if you're really old school. XML is at heart only designed to handle the text markup aspect of this. There's nothing in the XML standard nor in a basic XML processor that's going to definitely allow you to handle all these other types of content. So one of the things that happens is that people kind of design XML documents assuming that it's going to have all the functionality of HTML right off the bat, and that's not necessarily the case. There are other technologies that have come about to try to advance XML and make it more capable, such as Xlink, XPath, XPointer, and Xforms. But these, again, are more in the user interface realm. And as far as getting images and sounds, video, other bits of software, that's kind of left up to programmers. And not all programmers feel like going to the effort of trying to make XML work that way. So let's take a look at an example of the differences. For instance, here is an image element as you might see it in an HTML file. We see that we have a source, which is a URI, and then we have alternate text, which is text that's supposed to appear on the page in case the image doesn't. Let's take a look at a live example of that. There's a file you should have called htlimage.html, and this is just some standard printer's dummy text with some HTML code stuck in the middle to pull in an image, in this case the educator.com logo. So we see that the image element is simply part of the paragraph, and stricter versions of HTML actually require that. Some people like to put image elements right in the body tag, but really they're supposed to go in something like a P or a div. So it's really just more text in the paragraph, and if we take a look at what it looks like on the web here, and you can open this file in a browser, we see that the image just appears in the middle of the paragraph. If we look at it carefully, we see that here's where the image element was in the text. And basically the way that HTML formats it is just kind of a tall word, since it's a text substitution. So what happens is that when an HTML browser, when its tag processor comes across the image element, it knows that, okay, this text is supposed to be replaced. This image content is empty. There's no actual text that's part of the image element. I'm just supposed to replace where it is with whatever picture is referenced in the source attribute. So that's exactly what's happened here. So it treats it as kind of a very tall piece of text and reformats the rest of the paragraph around it. And what a lot of people will do in that case is, of course, put it in a div element, use CSS floats and that sort of thing to try to get the image to appear exactly where they want. But in principle, what we're doing is that a browser is looking at a particular bit of HTML, understanding that it has a meaning outside of text markup, and then making that action happen. And that's built into the web browser, and it's part of the HTML standard. In contrast, XML has no native way of dealing with images. There are various ways that people have tried to get around this. For example, they will create an empty element, give it a dimension in CSS, and then give it a background image to kind of recreate the experience of having an image element that sort of puts a box on the screen with a picture in it. This is kind of an odd way to do things, to have something that you consider to be page content, your image, to be part of the styling, and XML purists are up in arms about that. Sometimes the text is altered in a way so that the image code is actually put into some kind of text element in a way that when it's interpreted by the browser, it actually spits out the image on screen. There's some Microsoft Office formats that do it this way. And the disadvantage there is that if it's a complex image, the file size becomes gigantic in a hurry. So is there a way that it's supposed to happen? There's a way that you can make it happen. You need to put a lot of stuff in your DTD, and you need to work with something that are called external unparsed entities. And let's take a look at how this works. Another file you have is called xmlimage.xml. An external unparsed entity, unparsed means that your XML processor is not going to look into the content of the entity looking for XML data. It's going to assume that it's something completely other, and because it's not XML, XML does not describe a way of dealing with it. Here's what you're supposed to do if you're going to follow XML to the letter. You declare what's called a notation. All right, you're going to use, let's say, JPEG to handle JPEG images. And somewhere available to the program that has your XML processor as a part of it, there's something that lets it know how to handle JPEG images, how to make them part of your presentation of your XML data, whatever that is. Okay, then we'll declare an entity. We'll call it educator logo. And then we refer to its URI using a system identifier. And then we specify that it's notation data. The type of the entity is notation data, and that it's a JPEG. Okay. Then we'll declare an attribute for a particular element. So here we declare an element called image that's empty, and then we declare an attribute is list for image that's called source. And then we use it, the value of that attribute has to be an entity reference. And we'll just make it required, meaning you have to have that, otherwise the element doesn't work. And so the way we do that here is that we have our image element down here in the main part of our page. We have a source attribute, and then we make an entity reference, educator logo. Well, we said educator logo refers to this here, and the notation that's supposed to handle it is called JPEG. So you would refer to whatever it is in your system that's going to process JPEG data, and let's say if it's some kind of display program, it's going to display that JPEG as part of your page. Now, does this work? Well, probably not. If you were to open this in a browser, you'd probably just get something that looks like this. you'll just get the XML stuff showing up on the screen with nothing in particular. Why is that? Well, your browser probably doesn't have anything to handle that notation. Okay, notations kind of hark back to the SGML days of XML, the idea that as we create the means of creating these overarching systems of dealing with particular types of data, that they're going to emerge and be available to everyone. That hasn't happened, but that's the mechanism that's available to us in XML. So really what's happening is if you hunt around the web looking for how to put an image in XML, you'll find message boards, blogs, everything everywhere basically telling you, A, that you can't do it, and B, why would you want to do it if you're an XML purist? The truth is there is a mechanism, but it requires so much back-end programming and an infrastructure of people wanting to make it happen that they would have to coordinate in a standardized way, and that just hasn't come about yet. Another problem that arises when we're using XML is that of text encoding. Computers actually don't deal with text directly. Computers only like to deal with numbers. Yes, you purists at a deeper level is dealing with voltages that we're interpreting as numbers. Let's just stay at a higher level of abstraction. A text encoding is really like a number cipher, the kind of thing where you say A equals 1, B equals 2, that sort of thing. They're much more complex because your average text file needs to handle something more than just the capital 26 letters of the alphabet. It needs to be able to handle lowercase, needs to be able to handle punctuation, needs to be able to handle spaces, line returns, symbols, numerals, that sort of thing. But ultimately, every text encoding is based on that same idea. Let's take a collection of characters that are supposed to appear on screen and assign a number to each one. And there are really infinitely many ways you can do this. As computers have become more international over the last 30 years, a standard has emerged called Unicode, which is designed to assign a number to every single written character in every writing system ever created on Earth. Whether it's a casual language or more formal scientific type of stuff, Unicode aims to get just about everything that's ever been done, and they've gotten pretty far in that effort. By default, XML is supposed to use a version of Unicode called UTF-8 that just is basically designed to reduce the file size by using shorter encodings for more common characters. In XML, if you're going to use a particular encoding, it's helpful to use an encoding declaration. And in fact, if you look back at our XML image.xml file, I've put an encoding declaration right in the XML declaration at the top. If you're using UTF-8 or another one called UTF-16, you actually don't need to put it in there. Any XML processor, in the absence of any specific encoding declaration, is going to assume that you're going to use one or the other. However, there can be problems with this when you use certain text editors to format your XML. For example, in Windows, the standard basic text editor is called Notepad. By default, Notepad stores in a different standardized text encoding created by the American National Standards Institute, and it's not identical with UTF-8. So what results here is that you might even put an encoding declaration in your XML that says, okay, I'm using UTF-8, and then you actually store it in a different encoding system, which means that whatever programmer has come up with your XML processor, he's got to account for that. He's got to account for, I'm being told I'm reading in UTF-8, which is going to have the numbers mean a certain thing in a certain order. And what in fact is presented to me is the ANSI standard, so I have to work my way around that. This can require so much effort on the part of the programmer that they don't really feel like doing anything higher level with XML just to get this out of the way. And because Windows wants to stick with ANSI and not UTF-8 by default, a lot of supposedly UTF-8 XML files are actually in ANSI. And it can create a problem. Finally, there's the issue of media types. Media types got their start as email inclusions. Email was developed in the very early 70s and very quickly became clear that you don't just want to send your email text. You might want to send other files as part of your message. And so you needed to be able to tell your email program what exactly it had on its hands here in terms of an attachment. So the idea of MIME types came to the forefront. And as the web appeared, these MIME types migrated onto the web as a useful way for describing particular files that were being transmitted as part of a web interaction. Now, let's take a look here. If I go to the educator.com homepage here, and then I take a look at the source code, I can see an example of this media type. Here is a meta element which seeks to replace the HTTP headers that are transmitted as part of getting a web page to your browser. And it's saying the content type header should have this value. This is what is being transmitted is text in the HTML format, and here's that UTF-8. The character set being used is UTF-8. Most HTML on the web is sent as text, saying, please interpret this as text. And a lot of XML files are served as text as well. So sometimes you'll see text/XML as the media type of a particular XML file. This is very convenient because all browsers can deal with text files. But serving XML as text, specifically particular document types within XML, such as XHTML, it doesn't offer the full support of capabilities that the Web Consortium is hoping you're going to use to bring about their semantic web concept. What they would prefer you do is that you'd serve the media type as application/XML. Because XML really does have the kind of data type capability of a computer program or data file associated with a computer program. This offers more robust functionality. However, not every browser is going to support your XML when it's served as an application. For example, older versions of Internet Explorer, if you serve your XML or XHTML file as an application, it's not going to display it as a web page. It's going to actually treat it like it's some kind of downloaded program. It's going to open up a save window and ask you to download it. And then if you try to open it, it's just going to give you another download window. So unfortunately, the application aspect of XML is not as widely supported, or has not been as widely supported as it could be. And that's led to a hindrance of adoption. These problems and anything else that makes it difficult to program for XML kind of hold the standard back, and in turn, the sustained advancement of the capabilities of the web are also held back. So in this lesson, we've learned some of the kind of technical, nitpicky details that can make XML a difficult language to work with. These include conflicting standards, text encoding, misunderstanding or lack of support of MIME types, and all of these have an effect on how XML is implemented on the web, and thus how we can make use of the vast possibilities of XML in our web resources. Thank you for visiting educator.com.